be reduced any further either. Letter C, I have the square root of 32 is going to be in square root symbol, and square root of n squared in square root symbol. So I have my numerator and my denominator. 32, I look to break that apart. Does 25 divide into it? No. Does 16 divide into it? Oh, yes, it does, right off the bat. So I can break this into the square root of 16 times 2, and we'll move d up to here, but I'm just going to keep working across, simplifying my numerator. That's going to be 16, square root of 16, times the square root of 2. Then the square root of 16 goes away. I know that that's 4. The square root of 2, though, is reduced as far as it can go. So my numerator now, instead of being the square root of 32, is going to be the square root, or 4 times the square root of 2. Then I have to deal with my denominator. Square root of n squared. The squared and the square root sign cancel out. I get n just carries over. That's my final answer. Okay? Nicely done, guys. Alright, we have one left. I'm going to move it up to here. Square root of 49 over 121x squared. Oh, lots going on. I want to pick a color. There we go. Ocean. Very refreshing. I'm going to give each of the numerator and denominator their own little square root sign. So this is what I have now. Now my numerator, I'm just going to work across, simplify that. The square root of 49, oh, that one's nice. It's a perfect square right off the bat. It cancels itself out. It's 7. Denominator, I have numbers and letters. So now I'm going to have 121 and then x squared. They're separated. 7 comes across. The square root of 121 is 11. That one cancels. Perfect square, which is pretty nice. Square root of x squared, that cancels out. It's just going to be x. Wow, not too bad at all. 7 over 11x. Very nice. All right. Last problem, example 4. After a car accident, a police officer measures the length L, that's L, in feet of a car's skid marks. We've seen skid marks in the ground. The expression square root of 27L for this particular experience gives the car's speed in miles per hour at the time the brakes were applied. For part A, they want us to write the expression in simplest form. So I'm going to do part A right here. They want us to break apart the square root of 27L. First step, numbers, letters. Second step, break apart the numbers. So square root of 27, does 25 go into it evenly? No. 16 evenly? No. 9 evenly? Yes, it does. That can be 9 and 3. Square root of 9 is just 3. Square root of 3 stays under the square root symbol. Now I deal with my L. Now this is not L squared, so nothing cancels out. Instead, it's going to stay underneath the square root symbol. So my simplified expression is 3 square root of 3L. Again, these two mean exactly the same thing, but it's simplified. Okay, and that's our goal, to break this what's underneath the radical or the square root symbol down as far as it can be. Letter B says, in this situation, the skid marks are 125 feet long. Use the simplified expression to approximate the car's speed when the brakes are applied. So I think it's kind of cool, like CSI stuff. They can look and see how long the brakes were, analyze it. They have this formula for this situation, this scene that they investigate, and it's going to tell them how fast that person was going when they first put on their brakes. It's pretty neat to use math in real life like that. So let's see, they're going 125, or the skid marks are 125 feet long. So I'm going to put that in for L. I'm going to multiply 3 times 125, I get 375. Now the directions here say use the simplified expression, which we have here. This is my simplified expression, to approximate. They want me to approximate, which means I can use a calculator. Approximate the car's speed when the brakes are applied. Okay, so they want me to use a calculator to find the square root of 375, and that is 19.36. But then I'm going to multiply that answer times 3. And I get that this person was going 58 miles per hour. So I can say, oh, well, he was in a 60 mile per hour zone or 65 mile per hour zone. He was under the speed limit. He was doing fine. Or I can say, oh, this person was going a little too fast. That wasn't how fast they should have been going in this area. Just using math, we can learn so much stuff. So, all right, hopefully you're excellent at these puzzles. See me for extra help, and we'll go through them together. Have a good one, guys.